Good day, everyone, and happy Diwali to all of you who are celebrating Diwali. All right, so today in the house we have interesting question. We are going to solve minimum path sum lead code question number 64. All right, this question is a medium level difficulty wise, and there are two approaches to go for it. I mean, at least I know two approaches, and both are dynamic programming approaches. Either you can follow top down approach or bottom up approach. The top down approach is the memoization. You can follow the recursion with memoization. It's slightly difficult to understand, and it has not optimized space complexity as compared to bottom up approach. Now, the bottom up approach is an iterative solution where we can achieve the space complexity in a constant way, where the space complexity will be big of 1. So in this video our goal is to focus on bottom up approach, and if you need to understand how memoization work for this problem or any other dynamic programming problems, hit me up. I will create the video on that, but let's focus on bottom up approach in this video. All right, what do we have here? Here I have 2D grade, and we have to find minimum path sum. So you start from the very top, you reach to the very bottom, and then you find what was the minimum path sum that you needed to reach from the top to bottom, right? So here what do I have? Follow my screen. On the left hand side I have 1. Okay, now in this particular problem they have solution. This orange line is the solution. Let's follow that for a minute. From 1 I add 1 to the 3 becomes 4, I add 4 to the 1 becomes 5, I add 5 to the 1 becomes 6, and I add 6 to the 1 becomes 7. Now let's see if there are any other ways we can go for it to find the best minimum from this minimum path than this. Let's see. 1 plus 1 plus 1 is 2, 2 plus 4 6, 6 plus 2 8, 8 plus 1 9. 1 plus 1 2, 2 plus 5 7, 7 plus 1 6, 6 plus 1, oh no, 5 7, 7 plus sorry, my bad, 7 plus 1 8, 8 plus 1 9. So the approach here is not to only consider adjacent node, but we have to follow the progressive sum so that we can find the minimum path sum. What does that mean? Okay, bear with me for a minute. Okay, here what we are going to do, let's divide this problem into small sub problem, right? So let's just forget about the entire grid. Let's just say we only have these two cells, 1 and 3. Okay, in order to reach from 1 to 3, what is the minimum path sum? 1 and 3, right? Because those are the only two choices. So 1 and 3. Okay, let's add another cell. Add third cell here, the third column, which is 1. Now in order to reach to this column, what is the minimum path sum? Again 1 plus 3 plus 1. Correct? So let's divide this problem into sub problems, and then we can work our way around it. So for rows, there is only one way to go, right? You can only go to the right hand side. Okay, and in order to find the minimum path, we are just going to make the progressive sum and going to add the previous value to the current cell's value. Like in this example, for 3 we are going to add 1 plus 3, which is 4. For 1 we are going to add 4 plus 1, which is 5. Okay, that's for row. Same way for columns, right? Columns, you cannot go to the left hand side, you can only go to the bottom, right? So same way here, from 1 we are only going to add, for this cell 1 we can only add the top 1. So 1 plus 1 2. For this third row we can only add the row before that. We cannot go to the left hand side to add any values, right? So 4 plus 1 5. So if I had to calculate the value of this particular cell minimum path value, my answer would be 1 plus 1 plus 4, which is 5. Okay, so that's for row, that's for column. Okay, how about if you have the cell somewhere in the between? Now you have two options to go for it. Either you can go to the top to take the value from the top, because we are traversing like this, or you can take the value of the left. Either top or the left, top of the left, top of the left. That's how you reach to the bottom. For rows, there is only one possibility. For columns, there is only one possibility, but if the cell is in the middle, it has two different options to choose from to go for the path. Then we choose the minimum of both two. Now consider for this, for example, for phi, what is the best solution here? Either it can take 1 or 3, of course the 1, So we are going to compare both of the cell values. We are going to pick the minimum of those and gonna progressively sum forward. That's all the three conditions, that's all we need to know. Now put that into perspective. Here I have grid representing the same values in this grid. What we are going to do, we are going to update this grid with updated values. How? Let's first deal with the rows problem. Okay, for rows, what we are going to do, let's say I'm going to copy this for simplicity purposes and paste it here. Okay, we don't need this values, this value, this value. Let me get rid of all values first. Okay, as we talk, let's say our problem statement is only to find the minimum part between these two. So 3 plus 1 is going to be 4. You got the solution for that cell. Let's find the solution for this cell. The current value of this cell is 1. If I had to reach here, all I have to do, there's only one possible combinations, 4 plus 1, 5. Alright, if I have to reach here, there's only one possible combination from the source, which is the top. So 1 plus 1, 2. I have to reach here. The one possible combination, reach from the top. So 4 plus 2, 6. Alright, center, this is interesting. I have two possible combinations to go for, two possible values to go for, 4 or 2. 2 is the less than 4, so I'm going to pick the 2. So my current value is 5, 5 plus 2 is going to be 7. For this, again, I have two choices. Current value is 1, I can either go for 5 or 6. I'm going to pick 5 because we have to find the minimum. So between 7 and 5, 5 is the minimum. So 5 plus current value, that is 5 plus 1, that is 6. Wow. Okay, again, for this value, current cell value is 2, but I have two choices, 6 plus 7, I'm going to pick 6. So 6 plus 2, 8. You get the drill, right? At the end, bottom, at the last cell, we have the solution ready. We have the answer ready. We are going to pick between the two values, 6 or 8. 6 is the minimum. Current value is 1. So 6 plus 1, 7. And there you go. You have the answer. Pretty straightforward, right? So what we did, we divide the entire problem into sub-problem. And we are only going to calculate the value. We are only going to calculate the result or minimum path value for that cell. And if you go by that logic, we have three different conditions. Either you could go row wise, column wise, or if the cell is in the between where it has two different choices. Alright, let's roll this up. Let's code this out. If I have to code, I'm put my recording somewhere here, so I could code here. Alright, what do we need? We need to traverse the 2D matrix. How do we traverse the 2D matrix? With two for loops. Integer, first we are going to traverse through rows. So row is equal to 0. Row less than equal to grid dot length and row plus plus. So we are going to traverse till the rows. Okay, grid dot length give me the size of the row. Okay, and then inside that we are going to traverse to each column of each row. So for integer, column is equal to 0, column is less than grid dot. Okay, now this is interesting. I know what is the length of the row. How do I know what is the length of the column? Interestingly, all the columns are of same size. Okay, so I'm just going to pick the column of first row, and that is going to be size of all the rows. So column of first row, how do we get the size of the first column? You select, index it to the 0th, and then use the variable or property length. So that's how you get the column size in 2D matrix. And then pretty straightforward. We have done iteration. Now it's time to add the logic. What is our first condition? Here, if you notice something here, we actually started calculation from this for this all values, but we did not do anything on the first value because that's our base condition. We start our iteration or start our summing up from that value. So we are going to leave that value alone because that's the base condition we needed. So if the row is 0, right, or the column, oh my god, and the column is also 0, my bad, here is going to be double equal to because we are comparing, not assigning. If both row and the column is 0, that means it is the first cell, then leave that cell alone and continue to the next statement. That's our first condition. Second condition, calculating the value of the row. Okay, in order to calculate the value of the row, what we did, we kept the row same, but we keep adding the value of the previous column. Okay, summing up the value of the previous column. If you remember from this, right, for 4 we added 1, for 5 we added 4. So we kept adding the value of the previous columns. So here, if my row is 0, in this case, what I'm going to do, I'm going to say grade of row and column. That means I'm pointing to the current cell, plus equal to, I'm updating the value of that cell with previous column. So row is same, but the previous column, so column -1. Voila, that's for your row. Let's do the same for the column. I hope you got the logic. Column is 0. I'm gonna say grade row column. So we're updating the value of that cell now with previous rows value, right? Previous rows. This time the row would be previous -1, but the column would be same, because same column but the previous rows. Okay, same column and the previous rows. Okay, this is all right. And since we also have to continue from both of the statement, because we're only going to calculate the value of that cell and we're going to go to the next cell. So continue here, continue here. Okay, so far so good. Now, interesting one. If the cell is somewhere in the middle, then it has two choices, to top or the left. So let's do that. We can, since other if has already been added, we don't have to add another if. It knows that that's the last condition. So row and column plus equal to, plus equal to. Now what we have to do, we have to take minimum of previous row or previous column. So math dot min, then grade row and column -1, so previous column, or grade previous row but the same column. That should do it, I guess so. And now we have updated the grid in place, and as you can remember, we get the solution at the last cell. Okay, so let's return that cell from the solution. So return grid dot length L capital -1. So that's I'll explain you what this is, but let me first finish writing it. Okay, so why -1? Because the grid size is 3 3, right? So grid size is 3 and 3, but we start the indexing from 0. So 3 0 1 2 0 1 2. So this column, the index of this cell is 2 2, not 3 3. That's why we are subtracting 1 from the grid's last cell. Once that is done, let's run this and see if the test cases are getting passed or not. If not, then we'll, oh, it actually got passed in first attempt. Very interesting. Let's submit this solution and see if we have an answer or not. Speeding up. All right, interesting. 79 milliseconds, pretty fast. Yeah, faster than 89.52% of the users. Okay, that's good, I guess. Okay, so what is the time and space complexity? Space is constant space, because we are not using any auxiliary array. We are actually doing the calculation in place. Okay, so time complexity for this solution would be, space complexity for this solution would be big of 1. My bad, constant. What is the time? Okay, time complexity is rows into columns. How? If you remember, we did the calculation for each cell except the first. So ignore the first cell for a minute, but we did calculations for all the cells. Okay, that means we did rows into column. Here, how many rows do we have? 3. How many columns do we have? 3. 3 into 3, 9. So we did 9 operations. That's why row into column. You can also, if you want to explain it more further, then you can do minus big of 1 because we did not do calculation for this one, right? So we can subtract that. But in the end, while we calculate space and complexity, we don't consider the constants if we have bigger complexity in the place. So here we have rows into column in the place, so we don't ignore this. So in the end, your time and space complexity becomes big of row into columns, and space become auxiliary space in place big of 1. Well, that's pretty straightforward. And if you want me to create another video to understand how memoization work for this solution, I can do that if I get a time. But thank you so much for joining this one. It's been simple problem actually. All right, have a good one. I'll see you in next one. Cheers.